I don't give up easily when I'm not satisfied with my scores. And something you can always do is go back to your data. So I was kind of curious about outliers, and what I just did is I looked up the value counts for Y, right, which is the number of rings. Now this is a data set of over 4,000 rows, and you can see the great majority of the data points are in fact in the middle. Okay, and if you look all the way down here, like, just having like a couple of rings or like a lot actually end up being outliers. And it looks like if, maybe we start at like 23 is the max, okay, and 3 is the minimum, we get like more of the data points. And so it's interesting to sort of try. You could even maybe use 22 because there are 6 points here. So maybe 20, that would include it, sorry. And so let's just see what type of difference we would get in the scores if in fact we ignore, let's just call the rest of these outliers. And so we're going to let Y be only between, so what do we have? Between 23 and 3. Yeah. Okay. So make sure every value in here is between 23 and 3. Okay. So how would you do that first of all? What you would do is you would go back to your df, okay? Because you can't just change it in Y, you'd have to change it in X too. Okay, so what we're gonna do here, we're gonna make a modification and we're gonna say df, we're gonna limit it here, okay, equals what? Equals df such that, okay, this is conditional formatting, df rings, okay, is greater than, greater than 2, right? We'll count 3 in there. And I think for the and here, you want, gosh, is it this? Like a double ampersand? Maybe it's 1. And do you want df rings to be less than 24? Okay. Now, to get that to work, we would have to also check the df rings dot value counts to see if those in fact now are not present. Okay. Now let me check first that this actually works. Got an error. It says the truth value of a series is ambiguous. This I feel like this happens to me a lot when I end up trying this. What's the change here? The change would be, gosh, is it dot all? That's right. Okay, I'm gonna need to look it up. So let me show you how I would do that. You just put it in, okay, and then you want Stack Overflow. Okay, put it into Google. Look at that, right? I've looked this up before. Okay, so it does say you want the and here. I'll have to come back to another time when you actually this is the error that person got. And so this is using the bitwise and or, and is it potentially the parentheses is what is off here. So let me try that again. Okay, so basically we have the df rings and then using the and this criteria. Just ignore the any and all thing for now. Okay, and you can see now it actually does work. So I just need a parentheses, it turned out. Okay, and sort of like this is interesting because I would get this error before using the and. You sort of end up using these bitwise operator because this doesn't have a true value. Okay, it's not like true or false. And is looking for true or falses. But it's kind of cool that pandas allows you to sort of set up two criteria like this using these bitwise operators. Okay, so our point of doing this was to actually go back and now, right, we did this for all of our data frame and see if this improves our scores. Okay, I'm just going to try it on everything. Okay, first of all, the shape was 4,177. That's 4,168. We didn't remove that much, but we did remove outliers. Now this has like stuff that we've already sort of tuned, And you can see it's only slightly higher, but it is higher. Let's jump down to the one. This is the one that was being tuned. I was sort of tweaking with it just to see if I could do better. I'm a little curious here to see, can we get under that 2.13 after removing the outliers? And we do. We get 2.10. So it's definitely improved without the outliers, and sort of like forcing it to fit on the outliers, you know, that could affect even the model, right? Because these were sort of based on those outliers being there. And so you could almost like start this idea again, you know, and you could maybe do like, does lowering the max depth now sort of do better for the 2.10? Okay, I don't know. I'm not going to go through the entire process again. It doesn't. I think it's kind of fun to do it. But do note that it's something that hasn't really come up before, I guess, in these lessons, but it is standard. Like, so if you're going to remove outliers, you've got to have like a rationale. It can't just be because I want to improve my score. You know, it could be that, well, hey, we want to be able to predict 99.9% of the shells or whatever, 99 point something percent. And, you know, this covers that, right? This has all that in here. So, you know, the other thing is sometimes you can have very extreme values. In this case, I do feel like it's an either or, because I think you could certainly have, you can see now here lowering the samples does actually work, right? So we are starting to make kind of more gains. Okay, so always check, you can do what I did here. You can check sort of the different values of your Y. You could consider, like, you could even do something like this. Like, okay, so you've got your Y. Well, what about Y such that what? Will this work? That Y is, you could be like, what are my extreme values? I want to see, you know, when Y is greater than 25. Okay, it didn't show it there. Sorry about that. Let me see this. If I print it out, will that work? Okay, sometimes it has issues if it's like, because it's a series. And so if you just do DF, maybe that was the issue. DF such that Y is DF rings. So we could try that Y now is greater than 25. Okay, or yeah, so these would be sort of the extreme values. Now we actually modified it, so it might be empty. That might be the issue. We already modified it, but maybe you just want to look at like your high values, and you can see that it shows them. So you can modify your data to kind of like do that. Okay, I'm gonna check it again like this just to see. Yeah, and so that does in fact work. It's just we had already eliminated those. Okay, so you can always go back to your data to try to make improvements and potentially get rid of outliers.